During class, when we did the myriad of mobiles activity, you took a look at what happens to the number of possible arrangements of a set of objects when you have some objects that are repeated or identical objects. So this is known as permutations with repetition or repeated objects. All right, so the first example. In how many different ways can we rearrange the letters in the word cat? Okay, this is an arrangement of three objects, C, A, T, and there are no repeated items. Okay? We have a couple options here looking at using organized counting. We could do this using permutations, we could do this using factorials, we could even just list out the options. So if we were to list out the options, we would have these 6 different arrangements of the letters in the word cat. Using permutations to figure out the number of arrangements, we could use 3p3, okay, or we want to select all 3 letters. So that would be the same as 3 factorial, which is 3 times 2 times 1, so we get 6 possible arrangements. So either using permutations, or because it's such a small number, we could possibly just list out the options, and that's a perfectly fine way of solving the problem. Obviously, with larger numbers, we do not want to have to list out all of the possibilities. Okay. Second example, how many different ways can you rearrange the letters in the word egg? Okay. Now, egg is similar to cat in that we are still working with 3 letters. However, egg is different from the word cat because we now have repeated letters happening. So we have 2 G's in this word. Okay. So let's actually make a list of all of the possibilities that we have here. And before we start rearranging letters, let's mark one of the G's so that it's different from the other one. So if we mark one of the G's with a star, okay, so we've got E, G, and then G star in this 3-letter word, we can make basically the same 6 arrangements that we did with the word cat. However, looking at this list, we see that the first and second, if we remove the star, are actually the same. The third and the fourth are the same, and the fifth and the sixth are the same. So instead of having 6 total rearrangements, we have only 3. Okay? So we only have 3 different options here. And so what we're going to do when we have repeated objects or repeated letters, in this case, is basically divide out for the repetition that's happening, because we only want to count each of the arrangements once, but we can see here that we're counting each of the arrangements twice. And we're counting each of the arrangements twice because the 2-letter G's can trade places in 2 different ways, or in other words, 2 factorial ways. So what we do is we take 3 factorial because we have 3 letters that we're rearranging in total, and we're going to divide out for the repetition by dividing by 2 factorial because the 2 G's can be arranged in 2 factorial ways. Okay, so we get 3 factorial over 2 factorial, which ends up being 3. So we know there's only 3 ways in which we can rearrange the letters in this word. Okay. Next example, how many different ways can you rearrange the letters in the word wall? Okay, so again, we've got repeated letters happening here. There's 2 L's in the word wall, but this time we have 4 total letters. So we're going to take the 4 total letters, 4 factorial in the numerator, and divide out for the repetition that's happening because the 2 L's can rearrange themselves in 2 factorial ways. So we divide by 2 factorial, and we get 12 different ways in which to rearrange the letters in the word wall. Okay, next one. How many permutations are there of the letters in the word bookkeeper? Okay. Now this one's a little bit trickier because we've actually got multiple sets of repeated items. We've got 2 O's, 2 K's, and 3 E's. Okay, so if each letter were different, then there would be 10 factorial permutations because there are 10 letters in the word bookkeeper, but we have to deal with the repeated letters. So we're going to divide by 2 factorial for the 2 O's. We're going to divide by 2 factorial again to account for the two k's, because the two k's can also rearrange themselves in 2 factorial ways. And then we're going to divide by 3 factorial because of the 3 e's. And those 3 e's could rearrange themselves in 3 factorial ways. Okay, so we get 10 factorial divided by 2 factorial times 2 factorial times 3 factorial. So we're dividing by each of those pieces. Okay, which if we were to write it out in long form would look something like this. We can simplify by dividing out common factors, and the answer is 151,200 different ways in which to arrange the letters in the word bookkeeper. So the formula that we're looking at here, and you might see different variations on this formula, different letters used in place of N, A, B, and C, but the concept is the same. So the number of permutations of a set of N objects that contains a certain amount of identical objects of one kind, a certain amount of identical objects of another kind, and a third kind, and so on. The formula looks like n factorial divided by a factorial times b factorial times c factorial times d factorial, and you would continue that pattern in the denominator for however many sets of identical objects you have.